Good morning, and welcome to the first of our six-part technical training series on the Siemens LMV3 linkageless burner controller. Thank you for joining us. I'm Aaron Zeller, Director of Sales at SCC. Our presenter for this series is David Lehrer. David is our Senior Tech Support Engineer and Trainer and has been turning others into LMV experts for more than 15 years. For joining us today. Let's turn it over to David and get started.
Thank you, Aaron. Morning. Welcome to LMV3 series. My name's David Lehrer. I do training primarily here in Chicago at the SCC Training Center in Elk Grove Village. We also have tech support out of the Elk Grove Village offices. The Chicago numbers are up on the screen. It's from like 6:30 in the morning until 6 o'clock at night, and the customer service numbers are also shown. And I'd like you to be familiar with our combustion website, which has a vast and extensive information on products, on offerings of the webinar, such as you're watching today, data sheets, vast knowledge, and it's at www.sccombustion.com. So please review the website. You do yourself a big favor. Today we're going to do section 1. We're going to do an overview on the LMV3 product. We're going to do 5 more of these up to section 7 and 8, which is going to be at the Modbus and ACS 450 schedule shown. Along with this webinar, we are going to use this. We're going to provide it in the order that it's presented in the LMV3 technical instructions. You may already have copies of this. There's PDF copies available on the website, or you may have had a copy mailed to you in preparation for this webinar. Today, we're going to look at the LMV3, the little brother to the LMV5 series, linkageless burner control. You can see a family portrait here. The LMV3 features, it's basically a flame safeguard. It has dual microprocessors as an electronic flame safeguard. It's got 2 parallel programs running, just like the LMV5. It's got a linkageless fuel-air ratio control. It's got a dedicated actuator for air, a dedicated actuator for fuel, and an optional actuator for air control, being a VFD or PWM, and no linkage. It takes a remote firing rate. In other words, you have to send this thing 120 volts to increase the fire rate, decrease the fire rate, or a 4 to 20 milliamp signal from some external load controller, or you can control the firing rate through Modbus. What the LMV3 does not have is an onboard load controller like the LMV5. In that case, you have to get an LMV5 with an internal load controller. But many units today are using external load controllers because they simply turn it over to lead lag systems, master panels, BMSs, and let the LMVs do the flame safety and ratio controls. This is a common development as controls go today. It can be dual fuel. Typically, that would be gas and oil, but it can be straight gas. You can also do 2 different gases or 2 different oils, or any combination thereof. It has 2 rotary actuators, typically fuel and air, that can be used that are active. 3 of them get wired, so you would use air and gas to do a gas fire job, and then the same air actuator and oil for an oil fire job. So you wire up 3 servos, but only 2 of them are active on any fuel. It has the ability to control a variable frequency drive or a pulse width modulation motor control. It has both output signals on it. That's a benefit that the LMV3 has, that the LMV5 does not have PWM control. The LMV3 does have PWM, and PWMs are becoming very popular in the market today. It has built-in valve proving that you can use or not use at your discretion. Valve proving is an awesome way to do valve leak tests. It can be used in addition to or in lieu of a vent valve. And it is built into the LMV3. Simply by adding a gas pressure switch between the valves, you can do valve proving. LMV37 can do a revert to pilot. This is an awesome feature on small burners, such that when the load is satisfied and the burner comes down to low fire, Typically, the pressure or temperature will continue to increase until you turn off on your limit setting. That causes a post-purge, a shutdown, and then a subsequent call for heat would cause another pre-purge, and then go back to low fire. Revert to pilot is a feature where when you get to low fire, as opposed to shutting the burner down and going into a post-purge, and that becomes inefficient where you cool down the burners. Revert to pilot simply relights the pilot and extinguishes the mains, and it stands on the pilot. Then when you get another call for heat, it can immediately relight the mains and you skip the subsequent post-purge, pre-purge, and shutdown sequence. So it makes for a very rapid response boiler, cuts down the cycling time, increases the efficiency quite a bit. Fuel usage, there's inputs on the LMV that can take pulses from fuel meters. So now you can read the fuel usage on the AZL display. You can bring it to a touchscreen, or you can bring it to a BMS or automation. It's available as a Modbus point. And it has a Modbus feature. You simply take the LMV3 and add the OCI module, and then you can do Modbus communication. Today's presentation will show part numbers and everything for the 120 volt components. Contact customer support, sales, or tech support for pricing, availability, and application of all the 230 volt components. There's a whole 230 volt. They have different wiring, different settings, and different part numbers. LMV3, as you see it, is the flame safeguard. It comes in an LMV37, which is a single fuel unit, all those features that we talked about. The LMV36 looks identical. It has all the features of the LMV37, only it has two fuel curves in it so that you can run a gas curve and you can run an oil curve. The other difference between the LMV36 is the LMV36 does not have revert to pilot feature. So LMV37 has revert to pilot, single fuel. LMV36 is dual fuel and does not have the option for revert to pilot. An AGM60 is a fuel module that's used in conjunction with the LMV3 to make it dual fuel. So instead of running a single fuel servo, you see the green plugs on there for the air and the fuel servo. You see on the AGM60, there's two green plugs for the gas servo and the oil servo, or two gases as you see fit, plus a lot of white connections on there that are 120 volts. So all the 120 volt inputs, such as high gas, low gas, get switched over to high oil, low oil, and the different servos. So the AGM60 is a safety related called a force guided relay that switches from the gas settings to the oil settings, or from propane to natural, two different gases, two different curves. And it's a safety related relay that does automatic switchover. All you do is change fuels. It cycles down on one fuel, switches over to the other fuel, and brings it up on the second fuel at the push of a switch, so it does automatic sequencing of fuel change. AGM60 dual fuel module has a couple of options. It comes with a LMV36 to the AGM cable, and that connects the AGM communication between that module and the LMV itself. And then additionally at SCC, we make a stacking bracket so that you could put the AGM and the LMV side by side, like on the previous slide in your control panel, or to save panel space, you can stack them as the picture shows on the right, and it's got a hinged apparatus to it, so you can actually leave it all wired and you can flip it up and put your meters and test points and everything on it in place and cut down on the real estate used in your control panel. The LMV3 does not require a display, but it's a low-cost, huge addition to the unit. You will need it to do programming and everything else, but the LMV3, with the display removed, it runs. You can take it on and off as needed. It has to be connected with a cable, which ends up being a TDC combo. Is that basically a 7-foot RJ11 standard phone cable, like you'd find on all your telephones. And then it comes with a RJ11 flipper. And what it does is it takes the 4 pins on the cable and turns them over so that 1, 2, 3, 4 becomes 4, 3, 2, 1. So that allows us, by having a flipper, is that you can run a 7-foot or a 20-foot or a 3-foot cable as you see fit on the RJ11, and then take whatever cable you get and flip it over so it can be used with the burner controls. Additionally, to run the LMV3, you're going to have to buy terminal sets. Those would be separate, one for the LMV3, and if you're running an AGM60, you need another terminal set for the AGM60 as well. If you want to add Modbus to your LMV3, you need to get an OCI 412. It includes a cable, and it plugs in, as you see on the unit right there, plugs into X92, and then coming out of that module, and you'll get a Modbus connection that you can take to a BMS, to a touchscreen, to whatever you need to run Modbus, such as an optional SEC touchscreen kit. That would be a Modbus device, and it take all that data and present it onto your screen. So instead of just the AZL, you have a nice HMI. Or any other Modbus device that you have, such as your building management system, a master lead lag panel, or any other Modbus device that you see fit. It just adds the Modbus capabilities to the standard LMV3. Additionally, once you get the LMV3 in there, you're going to want some actuators. Actuators are pre-wired with 12-foot cables. That would be the limitation of distance from the LMV3 to the actual device. So you would use one for air, one for fuel. 12-foot cable is in there. They come in two different torque ranges, 27 inch-pounds and 90 inch-pounds. And you can also add NEMA 4. The entire motor is NEMA 4 with the exception of that shaft, and that shaft can put a NEMA 4 kit on there, and that puts an O-ring on the shaft, and now the entire assembly is a NEMA 4 rated assembly, the cover, the cord, and the shaft. The SQM33 raw motor can be used in addition to devices such as a VKG gas butterfly assembly. These we call VA, valve actuator assemblies. It's the servo motor plus the device on the other end. It might be a oil controller, such as a Hawk oil valve with brackets, couplings, and standoffs, as you see illustrated. It might be a particular OEM, like a rotary air damper on a Cleaver Brooks boiler. We have rotary air damper kits for the SQM33s. Or you can get the coupling and the brackets, and you can bolt it to any device that you see fit on your burner for OEM or retrofit. For flame sensors, every flame safeguard that Siemens has made and most other makes have flame rods. SCC doesn't sell flame rods. They're usually very specific and custom in OEMs and very simple to make. So you can use a flame rod with an LMV3. And then on the flame rod, if you want, you can add the step-up transformer, elevate the flame rod signal. This makes the flame rod more sensitive to the flame signal, more or less like an amplifier. The higher the voltage on the flame rod, the better the pickup of the flame presence. Otherwise, you can use a QRA scanner. The QRA2 is a smaller, simpler one used on many European burners, and it does forward and side viewing. Or the QRA4U, which is the one used on most US burners, which comes with a pipe mount and you use it on a sight tube. Additionally, if you take the QRA2, you can do a right angle adapter to kind of push it out of the way or put it straight in, whatever you see fit for your application. Or the QRA4 also has a thermal connection, which you'd put on the end, and that would give you thermal protection from the burner to the scanner. All the devices on the LMV3 series and all of the Siemens controls have 140 degree Fahrenheit temperature limitation. So if you get a hot sight tube on it like that, you could put a thermal standoff, and then your scanner will stay below the 140 degree limitation. For fan speed control, the first option is a variable frequency drive. Variable frequency drive, SCC out of Chicago, we sell Yaskawa drives, or we give you the programming you need to do Yaskawa drives. A1000, V1000 series are vector drives. And then you would have to add a speed sensor to your motor. A speed sensor kit would look something like this. That would have conduit connections, mounting to put it onto the motor, and the speed wheel that's on the other side of it, on the other side of the grate. We also offer a lot of documentation and support, wiring, programming. We can pre-program the VFDs for the LMVs, or you can give you the program sheets and tell you which parameters need to be changed. But there are a lot of technical support and documentation on the variable frequency applications. That's the first option for fan speed control. The LMV3 also has a fan speed option number 2, which would be the pulse width modulation, PWM controls. Pulse width modulation doesn't need a speed sensor. It has an electronic tachometer. The speed motors, the pulse width modulation motors, can't turn backwards, so you don't need the asymmetric disc. They always go forward. They're DC brushless motors. And the tachometers are very accurate for the feedback for fuel-air ratio control. One of the biggest applications of the PWM blowers is what we call PBAs, a premix blower application option. It's taking a spool piece, an addition, and connecting it to a PWM motor, such as Amatec, EBM, Fasco, any PBM blower, and the flange fits on there. So now you can take the air and gas into the blower, and the blower will do the premixing, and you can either control the air with simple PWM signals to the speed of the fan, or the fan speed plus an air actuator, which would be a butterfly in that PBA assembly, and a pipe connection, which would be the fuel inlet to there. So you can have fuel, air, and fan speed control on your burner application with a PBA and a PWM option. And we have documentation and support documents to go with it to help you with your application. The LMV3 can be connected to your personal computer for commissioning. You got free ACS 450 software. Put it on your PC. Brings in a commissioning document for reports. You need a USB interface cable. It's called an OCI. An OCI 41030 is a service level where you can add the fuel curves and set up the commissioning of the LMV3. Or the OCI 410.40 is the OEM version, which will give you settings to like flame failure response time and OEM specific settings. All of the OEM settings, of course, can be reached, and the service settings, through the AZL display. But if you'd like to commission through the PC, you can. And then the best part about the ACS 450, 410 software is that you can download your reports and back up your configurations so that you can do successive jobs, repeat jobs, backup replacement jobs, and you can pre-program all your jobs according to similar jobs from before just by having backup programs of all the settings that are in there. It's a grade 1. It provides the actual parameter backup so that you can build and restore units, and the report files are automatically done at the same time when you save them off to the ACS 410 software package. As a recap, you have a base LMV3 control, add a terminal set, get terminals in there. An AZL display is highly recommended, and of course the cable to go along with it, the TDC combos. Servos as needed, maybe valve actuator assemblies. You can add OCI for the Modbus support, such as an HMI. Scanner you're going to need, either a flame rod or a UV scanner. A VFD option if you choose to use that. And then the PC would be connected through the OCI dongle that you see shown on there. To put this all together, on the end of section 1, there's an order sheet, and you can get this in electronic format or through your Salesforce, but basically it would go through the units, pick your LMV 3637, pick your scanner, pick your servos, pick your NEMA kits, plug adapters, whatever you want to do. It just makes for a very simple order guide. And the section 1 ends up with all of the mounting hardware dimensions so that you can use it for constructing your retrofit or for your OEM package for the LMV3 equipment. Okay, that gives you an overview of what's on the LMV3. I look forward to seeing everyone on the balance of the series for wiring, programming, troubleshooting, specific information on VFD and PWM applications, and then finally the Modbus options and how to use the ACS 410 software. Thank you. Aaron, I'll turn it back to you for questions and answers.
All right, Dave, thank you very much for taking us through that. It was a good start and a nice overview of the LMV3. We got a few questions during the presentation, so let's jump right in. First one we got, Dave, is when do I use an LMV3 versus an LMV5?
That's a very common question. The LMV5 was the initial linkageless flame safeguard series that Siemens released. The LMV3 was added later, about 5 years after the LMV5, as a lower cost alternative for the smaller burners so that we could add linkageless economically to smaller burners as well. So the LMV3 only has 2 active servos. You need an LMV5 to do 3 or more servos at the same time, such as FGR, secondary air, or secondary gas. You also need the LMV5 whenever you do oxygen trim, because the oxygen trim module only is applicable to the LMV5. It's on the CAN bus system. So the LMV3 is a lower cost alternative, has less capabilities, but it's still a linkageless control used on small burners, and its intent is to be an economical approach to a smaller burner. LMV5 has higher torque actuators as well, all the way up to the SQM9. LMV3 has smaller servos, as it's intended for the smaller burners.
Okay, very good. Another one that came in is, can you talk about 2 fuel curves in an LMV36? Like, how are those used and how might they be used?
2 fuel curves is great. The benefit of the LMV3 on the fuel curves is, first of all, when you go to make 2 curves, you can make them gas for propane, gas 0, and then gas for natural gas, which would be like gas 1. So you can make both of the labels on the screen say gas, just gas 0 and gas 1. On the LMV5, 2 fuels, yes, but it's always gas, and the other one is always labeled oil. So if you want to make 2 different gases, backup gas, propane, methane, digester gas, 2 gases you can do. You can also do 2 oils, such as if you had heavy oil and light oil, you could set up 2 curves for that. You can also set up a hot and a cold curve. If you have a single fuel gas burner out west where you have a very cold morning, and then by afternoon you have a very hot afternoon, you can actually run a cold curve in the morning, and then with a temperature sensor you can switch over to the hot curve for the afternoon, and you can run 2 different curves on the LMV3 for hot cold applications or 2 fuels. So it becomes very flexible having the 2 curves on the LMV36.
Yeah, very good. I'd like to add to that just briefly. We've seen it used pretty well with gas and propane, where you don't even need a second fuel train at all, right? You don't need a second fuel train. You don't even need a second fuel actuator. You just simply run 2 curves depending on which fuel you're running through the fuel train into the burner, which can be a pretty nice way to take advantage of that. All right, another one that came in, we get this one quite often, so I'm glad this was asked today, kind of in this public forum. You mentioned revert to pilot on the LMV37. Will that ever be added to the LMV5? And Dave, take a shot at that if you like, and if not, I'll try and add a little bit.
All right, LMV5 revert to pilot. Sadly, never going to happen. LMV5 is a mature product. Revert to pilot is actually a backwards sequencing that won't be added. It'll be on the future products, which is the LMV6. So LMV5 will never have revert to pilot like the LMV3. LMV3 has it, and as it becomes more popular, like I say, in future releases, we will add it to the next release, which will be the LMV6.
Yeah, and I would just add briefly to that, the LMV6. So Siemens is continuously working on product improvement, and the LMV6 is kind of the next generation LMV project underway right now, and bringing a lot of really cool things for the future. A lot of fun things we'll be excited to tell you guys about as we get a little bit closer. But certainly, revert to pilot is one of those points that has become popular since the LMV5's release, or become more popular, I should say. and will be added moving forward, as David mentioned. All right, let's see. Looks like we got another one here that I think is a good applicable one to the group as well. Can the LMV3 provide night setback, or what some other manufacturers might call dual set points?
The LMV3, okay. Early in the presentation, I showed you that the LMV3 takes an external load control. So the actual call for heat, the turning the burner on and off, is at the mercy of an external load control, such as a lead lag system or an RWF5 or a building automation system. The set point, LMV3, doesn't have any set points. So clearly you can't change two different set points on the LMV3 since it doesn't have one. The set point is a function of the external load control. So an RWF5 has two different set points in it. You can digitally switch over from one to the other. Building automation can have an infinite number of set points based on outdoor temperature or occupancy or whatever criteria you want to have. And the external set point can be done to the load controller, which would be external to the LMV3. So you can run as many set points as you want. It's all a function of integrating it with your load controller or your BMS, and really has nothing to do with the LMV3 since the LMV3 doesn't have set points, doesn't require set points. So a lot of flexibility, and it's all integrated into the load controller versus the flame safeguard.
Yeah, I would argue that you mentioned a lot of flexibility. It's a pretty nice. It's actually kind of nice that there's not an internal load controller in some ways, because you can get as elaborate as you like with external load control if that's necessary for your application. All right, and the last question. This is another good one we get quite often, and it's a little bit difficult one to answer, but I think it's worth a bit of discussion here. What is the largest horsepower burner? Or oftentimes we get asked, like, what's the highest BTU or largest burner you can use with an LMV3? And go for it, Dave. Take that and run with it if you would.
LMV3, you can use it on a 5,000 horsepower burner if you want. That's a bit of an exaggeration. The limitation on the LMV3 is not horsepower. The limitation on the LMV3 is the torque required to move an actuator. I mean, a actuator device such as an air damper. Air dampers are usually the heaviest device on a burner. A gas butterfly valve is usually pretty easy to move. Oil controllers, oil modulation valves are pretty easier to use. Air dampers in the US tend to have a heavier hand, and those are the ones that take some real torque is to move some of these air dampers that we have. But the limitation is the torque on the air damper servo, not the horsepower of the boiler. So an LMV3 can be used on any size horsepower as long as you can take the torque requirements of the SQM33.
Yeah, and I'll just add to that briefly. For a long time, the SQM33 was only available in one torque, which was about 30 inch-pounds. And I guess a little over a year ago, a newer version, a higher torque version of the SQM33 came out. It's called the SQM33.750 or 750, and that's available in a 90 inch-pound torque rating. So in the last year or so, LMV3s can be applied even larger for that very reason Dave mentioned. We've got a higher torque actuator that can drive a larger air damper now. If you had a very simple burner and you were only using the VFD on air and a single actuator on gas, I don't know that Dave's exaggeration isn't an exaggeration at all anymore. A 90 inch-pound actuator could turn an 8-inch gas valve all day, and you can get an awful lot of gas through that. So it really is application specific. All right. Well, that covers all the questions we received today. So thank you again for joining us. We really appreciate it, and hope you all have a great day.